Hello class, welcome to your second lecture on inventory management. In the first one we dealt with an overview and Q models. In this lecture we'll be looking at P models, and we'll also take a look at solved problems that are available at the end of the chapter. So unlike a Q model, which tailors the timing of orders using a reorder point to the order quantity, with a P model we basically establish a fixed interval between our orders. This is really very common in industrial distribution, we could say, and so we call it a periodic reorder system. That's where we get the idea of a P model. Yeah, so if you're Ace or True Value or some other hardware store, most likely there's a corporate distribution center that services your inventory needs. And when you need something, you just simply tell them what to put on the next truck, or a grocery store the same way. You know, the distribution center has a schedule by which you know when they're coming and which requires you to place the order at a particular time in order for it to be included on that next shipment. So that's what a periodic reorder system is. In Statesboro at one time, I believe, if I'm remembering it correctly, a former student told me that they got their shipments in from, this was a Chick-fil-A store, that they got their shipments in on Monday and Thursday. Of course, they're closed Sunday, right? So it's easy. They have a 3-day order interval. And it seems like the lead time was 1 day. So they would say on Saturday what to put on the truck that came on Monday. They would say on Wednesday what to put on the truck that came Thursday. The order interval was 3 days. The lead time was 1 day. So just kind of getting going here, we don't really put constraints on the size of the lot. And as far as a cycle inventory perspective, holding and ordering costs are the relevant costs, but we're not really minimizing costs here. More so, we're just conforming our supply to the logistical system. We're still dealing with independent demand items. And we really do, in this case, feel that lead times are certain. We're not really thinking about placing an order, Chick-fil-A store, and the warehouse or distribution center supplying us doesn't have what we need. So we think about supply. Supply is something that's certain, and lead times also something that's certain. So P is the order interval or the period between reviews. T is the target inventory level that we're trying to establish or come to with our order. So the picture looks like this. You'll notice that the time from one order until the time to the next order, that order interval is what's referred to as P in this chart. You see it labeled down on the horizontal axis. So that's the period between orders. It's the order interval. Lead time is labeled L. So here, instead of having a protection interval of only the lead time, which is what we had with the Q model, we have a protection interval for our safety stock of P plus L, the order interval plus the lead time. Another way to say that is when we place our order, we want to make sure that our inventory position is sufficient to last us until the next order arrives. So what shows up on the truck tomorrow better last us till the next truck comes. That's the idea. So we want to protect ourselves with our order and safety stock against stock out during the entire order interval plus the lead time. The target inventory position then is the position of inventory that gives us that assurance of protection during the protection interval. Well, let's go back to the bird feeder example and work through a P model with that. You may remember that demand was 18 units per week, and when we started introducing variability, we gave a standard deviation of 5 units per week to demand. The lead time was 2 weeks. So just by way of review, in the Q system, we found an EOQ of 75 units and a safety stock of 9 units, which gave us a cycle service level of 90%. So we want to look at a P system in order to see how that compares with this Q system. So P is going to be the time between reviews. Typically, we wouldn't convert an EOQ to P. It would just, the period would be given by the logistical system that we're interacting with. But in this case, we can just, so that we can more directly compare our EOQ results with our P model results, we're doing that. And so an EOQ of 75 units, if we're using 18 a week, would equate to a period, an order interval of about 4 weeks. It's slightly more. If you divide 75 by 18, you're going to get 4 and some change. So let's work with a period of 4 weeks. Lead time is 2 weeks, so our protection interval, P plus L, is 6 weeks. If we multiply the square root of 6 by 5, which is the standard deviation of daily demand, that'll give us the standard deviation of demand during the protection interval. So sigma of P plus L is 12.25 units. With a 90% service level, we're going to multiply the 12.25 by 1.28, which is the appropriate z-score, and we end up with 16 units of safety stock, which enables us to solve for our target inventory level. So the target inventory level is what we expect to use during the 6-week protection interval, plus safety stock. So we're using 18 units a week. In 6 weeks, we expect to use 6 times 18, or 108 units. Safety stock is 16 units, so our target inventory level is 124 units. So that's how much we want to have as our inventory position the moment that we've placed our order. So if we, let's say, had 24 units on the shelf, we would order 100 more. Right, we'd subtract the 24 from the target because we already have the 24. To reach the target, we only need 100 more. So the order quantity is derived from the target minus the amount that we happen to have on hand when the order is placed. So, the P system, as you can tell, it's really convenient because we can have an established logistical system that we're just sort of jumping on the bandwagon with, and we can order all kinds of things just on this same schedule. Single order, share the shipping cost, the truck's coming anyway. It's a sort of simpler system, and we only have to worry about how much inventory we've got on the shelf when it's time to place the order, every other week, or, maybe every week, every 3 days, whatever it is, but we don't have to have a perpetual record, and we don't have to be watching this thing 100% of the time to know that we've reached the order point and place our order. It's a good system, maybe not for A, inventory items, but it is a great system for B items and C items where we're willing to take a little bit of simplicity in terms of management and headaches because the item isn't so critically important as an A item might be. The rest of the slides on this slideshow are solved problems from the end of the chapter. I've just included the ones that relate pretty much to what we're doing in our class, so maybe it simplifies things a little bit from having to dig through the book to look for those particular slides. I will not talk over these. I think they're fairly straightforward and they can be followed. Of course, if you have questions, you're welcome to get in touch and I'm happy to help you if there's anything that needs clarification. Take care. We'll catch you on the next lecture.